Good. So again, welcome everyone. Welcome to our joint webinar together with our partners, Soil Essentials and AS Communications. This webinar will be recorded and sent to you after the webinar. And if you have questions during the webinar, please put them into the Q&A area. We will discuss them after the webinar. So today we will discuss if an autonomous tractor is the solution for today or tomorrow. We will also give you an insight on why AgXeed was started, the challenges of a farmer in the UK, talk about the most important considerations before buying an autonomous tractor. And then first, let me introduce today's speakers, Joris, Graham, and William. Joris is the CEO and co-founder of AgXeed. And before founding AgXeed together with his partners in 2018, he worked for years in the semiconductor industry for agriculture machinery at John Deere, Lilly, and Echo. The technical developments he realized resulted in a dozen patents for these employers, and this makes Joris a highly respected innovator and thought leader in the field of agriculture and autonomy. Graham is a qualified mechatronics engineer and is the hardware director with Soil Essentials. His primary role within the business is machine control and maintaining EssentialsNet RTK, the UK-wide GNSS RTK correction network. With over 30 plus years of experience in agriculture, Graham has an enviable breadth of knowledge, expertise, and enthusiasm for precision technology and autonomous solutions. William is a fifth-generation farmer from Cambridgeshire, England, and a CEO of AS Communications. He is passionate about food production, farming, the environment, and taking any opportunity to promote the virtues of UK agriculture. He started his business in 1989, believing there was an opportunity for an electronics and technology specialist within the modern agriculture industry. Then, as you know, this is a joint webinar with our distribution partners in the UK, so Soil Essentials and AS Communications. Let me introduce the companies really shortly. So Soil Essentials is the award-winning precision farming pioneers based in northeast Scotland. With 20 years of experience, they have seen many twists and turns along the way. Their enthusiasm for being at the forefront of new technologies and wish to push boundaries is ever present. AS Communications is a trusted supplier with over 30 years experience. Today, the ASC group of companies supplies many traditional and contemporary technologies and is often the first to bring new technologies and equipment to the market. So now I will give the floor to Joris to tell us the story of AgXeed, what triggered you to leave the big agriculture and machine building companies you worked for and to start your own company with your partners, Joris.
Yeah, thank you, Leonie. Yes, as you said, I worked in the past for a couple of companies who were doing machinery. And during that time, of course, I came into contact with many customers, with many farmers. And at a certain moment, farmers started, certain farmers, most of the time, maybe the more innovative, the more looking to the future farmers who asked me the question, is this the only thing you can do? Only thinking in bigger, bigger, bigger. And if we draw the line where we were 30, 20, 10 years ago, and we draw the line up to 10, 15, 20 years further, then we will have tractors around to the 700, 800, 900 horsepower, and the weight is going up and up and up. But you could not come up with some more clever solutions. And although they were not really talking immediately about autonomy or something like that, or they were challenging if we were going into the right direction, which was triggering me. And actually, at the same time, the company I was working for, I talked also about new technologies. And at a certain moment, they said, you are too far down the road. Stop with talking about, in that time also about robotics and autonomy. This is not the way we want to go. This is too soon, and focus on what we are doing now. Yeah, and that was step by step, more and more the trigger to start our own business. And now we are 4.5 years down the road, and we are commercially, our machines are commercially available. We have the first machines into the field. Many hours already done with autonomy, and it is becoming even more interesting. Sorry, Leonie, you are on mute.
I see. Sorry. Thank you. Well, thank you, Joris. That's very clear. And now back to Graham and William to see if we are currently still see the same or similar challenges in the UK. And yeah, where both of your companies operate, of course.
Yep. Good afternoon, everybody. Thank you all for joining us here today. So yeah, we're going to start just with some challenges of farmers that we see in the UK, and some of the challenges that we think that autonomy can play a part, at least in trying to alleviate. So starting with the pressures of scale as a beginning, very much as Joris said, for the considerable past, we've seen farmers increase the scale of their businesses to face the challenges of efficient crop production. For many of them, this has meant investment in large and very heavy machinery to try and achieve the required output levels. Many will consider themselves to be over-kitted, trying to tie up working capital into assets that are required purely to complete operations with a minimum of a time input. As a side note, we see the cost of machinery isn't necessarily linked to the size of the machines either. So as an example of that, a 6-meter machine isn't necessarily double the cost of a 3-meter machine. As we're aware, lack of skilled labour is the major driver in the minimum time input requirement. Similar to Joris's comments, I was recently at a tractor dealer where I was getting an explanation of the necessary or options that are now available for in-cab comforts that we see in most new tractors being sold. We think that this is really simply an enticement used to bring workers to the machine cab, where skills, experience, and sometimes predefined work plans can be compromised in an attempt to simply getting the job done on the day. Moving on to sustainable environmental practices, farming with this large high output machinery has a consequence of significant weight. This is obviously not a great thing. Will quickly make a rod for your own back, creating soil compaction problems and starting that good old never-ending cycle of remediation that's required to try and remove that. Traceability requirements, ever increasing all the time, evidence demonstration of environmentally practice becoming sort of standard issue, probably more beneficial at the moment for growers to produce that information, but as we know, that will probably move forward to being a mandatory requirement in the fullness of time. The management of time is obviously a big one for smaller businesses as well, probably more so this example for smaller businesses, where there's a need to balance the time required for farm work and to try and get enough time to manage the management strategy and the actions that are going to be happening. So many farmers in our region have chosen to diversify their businesses to remain viable, which is an example, of this requirement. And this can often mean that sitting on a tractor, although it can be quite enjoyable, it can be a frustrating consumption of time that's required. And it's not the most efficient place to run a business, especially when the requirements of that business can fall outside the normal workings of the farm, and aren't necessarily complementary of the standard farming calendar.
Yeah, thanks, Graham. So just to add to what Graham said, really, labour shortages, we see that all the time, and only in the last couple of days, we've seen on Facebook locally, every farmer is asking for a harvest student. And wind the clock back 20, 30 years, you'd have guys banging on the door, you know, all the local children wanted to work on the farm, wanted to drive the tractor, but that just seems to have gone. So we've just lost that source of labour. And we can't have a discussion really without talking about climate change. And the two photographs I've got here are the same field. It's about 100 yards apart, but they were taken 12 weeks apart. And we're constantly battling with these big lumps of weather that we seem to get these days. You know, we've got 6 months of dry and then 6 months of wet. And again, as Graham said, the weight of the machinery on the field is, in my opinion, causing us quite a lot of problems and quite a lot of issues with the soil compaction. So if we want to fix that, we need to remove that weight from the ground. The only way we will achieve that is by going towards the automation route. We simply cannot have 20, 30 people back on the land driving machines that weigh 2 or 3 tons. That's just not an option to us that we have these days. So, you know, let's have a look at it. Where were we? 1960. Traditionally around here, we'd have had a track marshal or a little cat. 4.5 tons, and where are we today? In the early 2000s, we moved over to the rubber track machines, 17.5 tons. So they're a big, hefty lump of machinery, packing the soil down. Admittedly, the work rate is fantastic. You know, we get some really, really good work rates out of these machines, but it's as Joris said, it's time to change. It's time to think about doing something different. You can see, you know, it's well documented. You've only got to listen to Tim Chayman from the Controlled Traffic Farming Group to know what damage can be done and how much that can reduce the crop yield by. You know, here's a classic picture. You can see every wheel mark across the farm there. It's obvious that will have reduced the yield in that particular crop, in that particular situation. It's been well documented that a 5-ton wheel load on the surface in 1 year can permanently depress yields by 2.5%. That's generally reckoned to be a standard wheat crop. If you're looking at veg crops or root crops, that can be significantly greater than that. And one of the things that I've learned over the years is that we need to consider soil as a material. And every material has properties. And if we go back to our basic physics lessons, we learned about the properties of a metal or of a plastic, and we learned that everything has an elastic property, and then it has a plastic property. And if we put a lot of strain on a material, it will damage it to a point of which it cannot be repaired. So, you know, can we go full circle? Can we go back to the 3, 4, 5-ton machine? Can we improve our soil quality? Can we improve our yield? Can we reduce our fuel consumption? Can we reduce the labour input on the farm? And the answer to that, I believe, with the AgXeed technology is yes. When again we take the Challenger and these bigger tractors, they consume big volumes of fuel, actually physically moving themselves across the field before we actually engage the soil engaging equipment. So for me, we're at a very exciting time in agriculture. We're at a point that we can improve everything that we do. We can lower our carbon footprint. We can reduce our reliance on fossil fuels, and we can do all of that with the autonomous or driverless tractor. I have to admit that this is a picture taken on one of my own fields, and you know, plainly the result of that is not going to be good from an environmental point of view. You know, we've got nutrient leaching, we've probably got pesticides and the nasties leaching into the watercourse, and plainly the yield in that area is going to be significantly reduced. And as it happened, that particular patch of field grew a lovely flush crop of black grass, and I had to spray it off, so actually it yielded nothing.
Thank you, William. Thank you, Graham. That's really insightful to hear, but also very unfortunate. to learn that farmers in the UK are still facing challenges. Looking on the brighter side, Joris, could you tell us something about the experience of your first customers, farmers who are actually using your autonomous tractors, AgBots? Do you see your dream coming true?
Yes, and we are making more and more hours. The machines in the field is growing, so the experience is also growing exponential. And especially in the last couple of weeks, it is really great to see how many machines are now working autonomously. And you have to imagine that, unfortunately, the pictures I see from the UK are also happening over here. So it is not related to the UK. And farmers saw that it was starting to rain these days. So last week they had to do a lot of work. And some farmers were really making 150 hours a week with these autonomous vehicles. So you have to imagine that some machines made in 5 months 900 hours. And if you see then these machines running through the field during the whole weekend from Friday in the morning till Monday in the morning, hardly not stopped, yeah, which driver is going to do that? And then also with really heavy implements, I mean subsoilers, doing this all the time. Yeah, really great to see how that works. And what we also hear is that farmers are who are using now the portal are also glad how well they can plan the fields. So much better than they could do with the old GPS systems. They really know what I'm saying into the portal, what I'm doing in the portal. That is also going to happen in the field. And now we have to see. I think that Graham was making. Or Will was making a very nice example of about the materials and what we learned as mechanical engineers about the material. And now it is interesting to see if we are going to work with lighter machines, and we are talking about less kilos per square centimeter. Yeah, if we can improve the situation again. So we have a couple of farmers, but this is a 200-hectare farm in near Mannheim. That's the vegetable region in Germany, and this farmer already came to us very soon. Really excited about the product and really wanted to have the product. He has now since a couple of months this machine working. I think the machine made now 350 hours. And yeah, if you see same thing, how that is going, and also what he is saying here, he's surprised about efficiency, the soil protection, and that the machine can drive day and night.
Okay. And Soil Essentials and AS Communications are your partners in the UK who are supporting these customers, for example, and will support the new ones, correct? Graham and Will, is this an easy job, or how much hand-holding is needed? How much support do they need?
Yep. Well, we would hope that the process of beginning with an AgBot to be relatively straightforward. First and foremost, this is down to our confidence in the product. With the AgXeed portfolio, we have a very well engineered portfolio of machines that are specifically designed for automation. This is very important as it combines the necessary hardware and software required for a robust machine with the international safety standards for safe operation. Additionally, the standard linkages that are on these machines and power takeoffs allow it to be easily integrated with the current machinery on your farm. So there's no extra work to be doing there, and they go straight on to your existing machinery. As a very close second, we have confidence in the people. AgXeed themselves, as we've heard, has been formed by the best of industry professionals who have the knowledge and understanding to present these products and tools for successful field operations. Similarly, for ourselves at Soil Essentials and AST Autonomy, we've been developing the skills and experience to link the advanced technologies that are available coming onto the market to our local areas, and we've been doing that for a very long time. For us, this is really just the next step along along the road. As we do with many other technologies, we try not to dictate too much to farmers how the system should be run. It's more about presenting the tools to the producers and working with them to create the right solutions for their business moving forward. So yeah, getting started, as we say, is really quite straightforward, but there are some key training objectives that we need to complete before we can get working with an AgBot. So the accurate mapping of field boundaries and areas of work is a key objective to be completed for any kind of autonomy or safe autonomy to start. So that's a straightforward process that's done on foot, following a strict workflow to gain those accurate boundaries. Once we have the field boundaries, we can load those up into our online portal, or the AgXeed online portal, and arrange them so that we can start to add machinery and create jobs. So this allows farmers, growers to plan out exactly the work that they want to be happening on the fields, even months in advance. So that obviously allows everything to be nailed down a long time before it's actually required. The final piece of the puzzle is actually controlling the robot to do things like attach machines and navigate to the start of the working area. So there's hand controls to perform these functions, which we would provide training for, and that allows operators to get used to the machine, get it into its working environment, and start off that work process, the autonomous work process, I should say. Other considerations, locations of land parcels and logistics for moving the AgBot around. These are all things that we can help to plan with you, as well as the logistics of the AgBot. So setting up alerts for the AgBot for things like fuel, seed and fertilizer, so that you know when integration with the machine is required, and you can plan better around the actual workings of the machine.
Yeah, so how much hand-holding is required? Good question, and I'm going to answer it in a slightly different way. We are, as been described, a technology company. We've been supplying auto steers into the market for many years. We've got great experience of joining electronics and great big heavy pieces of machinery together. Now, I took the opportunity of an early harvest this year to have a tour around and look at the autonomous vehicles that were about. There's lots about there. There's some really great technology, and there's some really clever guys developing stuff all over the world. And I decided that this year we're going to go and take a look at this, and if it's suitable for our marketplace, we'll take it on. It wasn't long. I hadn't been with Joris and his team for probably more than 10 minutes to realize that they've got a fantastic passion. They understand how to build a product and build a reliable product. Everything just seemed to be right. It's a conventional tractor. As Graham said, you can hook a conventional implement on the back. So there's lots of things that didn't need to be done to make this fit into a farming process. And then I thought about my own situation. Could I make this work in my own situation? And of course, I've diversified quite heavily, and I could see it working for me. I could see it working well. I could see that it could enhance my operation and allow me more time to concentrate on my diversification business. The final thing was that the machine was built locally. So, we can drive to the factory in under 6 hours, and it was important to me that the products that I was bringing to the market were easily accessible. Spares were easily accessible in an emergency, and hence, really, it was a very clear and very sensible decision for us to take on the AgXeed product and to bring it to the UK marketplace. And hopefully in a few weeks' time, we'll see the first 2 or 3 units arrive in the UK.
Okay, well, thank you both. To wrap it up, of course, with the very important question and actionable question, what are then the most important considerations before buying an autonomous tractor? Graham, Will?
Yeah,
Graham, you go.
I'll go first. Yeah, I guess from my point of view, it's perhaps the what, the where, and the why. Sorry, the what, the where, and the who, and the why will maybe take care of itself. The what would be, you know, what is it that this machine can do on your farm? So what is the laborious, repeatable task that this machine could get started with to get everyone on the page, to get the machine working, to make sure that there's an understanding, the biggest bang for buck, as it were, the repeatable task in that. Secondly is the where, thinking about the layout of your farm, where this or land, where this machine could work, and how the logistics of that will all piece together to make a solution as we would want. And then finally, it's the who. So who would need to integrate with the machine? Who as part of the team needs to be brought on board for training, for you know, really buying into the system and making sure that that it's going to be a success. And then, as I say, hopefully, if you can answer those three questions with positive result, then the why takes care of itself.
Will, do you have anything to add to that one?
No, Graham's explained that very well. I think I would ask, can you see a reason why you can't put a autonomous tractor into your system? You know, is there any reason why it wouldn't work? And if you can come up with a reason why it wouldn't work, then can we come up with a reason why it should? You know, it's an open discussion point for everybody to consider.
Yeah.
The other thing to mention, of course, is which we haven't talked about the actual machine itself, but we have got the three models of machine available, ranging from the 75 horsepower up to the 150 horsepower. So really, we've got a machine to fit every potential application in our agricultural environment.
Okay. Joris, do you have anything to add from your point of view?
Yeah, what people also have to consider is that because you don't have a cab, these machines can, for example, also work in two directions, which gives it also more useful hours or other options. So, for example, with a four-wheeler, we can put a front mower behind the machine, and it will have a rear-wheel steering is going into the other direction. With a three-wheel steered machine, if we are spraying, then we go, then the wide front wheel, let's call it front wheel, is then the direction. But we also can go with a mower or a mulcher in the other direction. We have done the same tricks with the track machine. So in Eastern Germany, the machine has worked with the mulcher for many hours, and then going backwards. And that's the easy thing of a robot. The robot doesn't matter which direction it goes. And what you also have to consider again, that how much data the portal will give you and how you also can improve there. So this is not only up to the choice for a robot, it is also the choice for a very powerful portal behind it, where you can manage basically your a big part of your farm.
Okay. Well, that's very clear. Thank you all. Then we're at the end of the webinar. So many thanks to Joris, Graham, and William for the information. Thank you to all the attendees for your attention. Now we can proceed with the Q&As. Please put your questions in the Q&A section, and We will get to them in a minute. So already the first questions were coming in. So one of the first questions is regarding the autonomous software equipment or equipment, how much of the support interaction can be completed remotely, Joris?
Yeah, that's a very good question, because that's also a very interesting part of the portal. We can do most of the service from remote. And this will be also a very powerful tool, not only for the farmer, but also for our distribution partners like Soil Essentials and AS Communications, that they can fix already a lot of problems remotely. So you have the system is in such a way that the farmer can make all the decisions. So if he wants that somebody is coming into his portal and is looking with him, then he has the right to say, okay, you can go into the portal. He also can say you always have access to certain data. So the farmer is controlling the data, but it is up to him how much people can help him, service him. And that is the very great. The portal is a very great tool to do that. So easy, you can get easy support.
Okay, that's clear. Another question is, what is the lead time of machines? Will, Graham?
Yeah, so we're taking orders for harvest this year. So if you want a machine for this autumn's cultivations, we would need to have an order by the end of next week.
Okay, that's clear.
Yeah.
Then another question is, how many units have been built so far, Joris?
I think we have built now around 30 machines. And we have now machines running in Australia, Canada, Germany, the Netherlands, and there will now go in Lithuania, and there will now go a machine to Hungary. There will go a couple of machines to France and to the UK, and that is basically the area where we want to grow in the next coming year.
Okay. What are the operations that you anticipate the AgBot undertaking in the UK, Graham?
It's an interesting question. I can see the AgBot working in different scenarios. So repetitive jobs, things like grass mowing, where areas are defined and clear, we can see great potential in these sorts of things. But equally well, working with smaller producers, maybe working as part of a team, as an example, as a drilling machine. Obviously, a 3-meter drill on an AgBot will work away and cover quite a bit of ground in front of somebody else who was perhaps rolling behind it, filling it with seed, doing all that kind of stuff. And at the end of the day, you're finished with a complete job done.
Okay. And then another interesting question, how to detect a machine failure. Is the operator notified of warning on a platform, e.g. a seed tube is clogged, for example? Joris?
Yeah, if we are talking about a robot itself, then all the messages are coming on your phone. So if there is an error code, it will come on your phone. If you want, you can also say that the dealer is also warned immediately. If we are talking about the implements, then it is up to the implements you have behind it. So if there is no sensor and there is no connection and there is no ISO-bus available, then of course you will also not get a message. But there are now, we are already working with 7 partners on more or less standard ISO-bus, and then all the error codes or the warnings can also come from the machinery into the portal, and the portal, of course, also has a connection with your smartphone, mobile phone. So if there is a blockage and there is a sensor on the machine, you will get a warning.
Okay. Will, maybe one for you. What is the on-farm cost versus a comparative conventional tractor?
Yeah, so for a comparative tractor of the same horsepower, the on-farm initial cost would be greater, but the running cost over the lifetime of that machine would be less than a conventional tractor if we take into account service costs and we take into account labor costs and also the fuel costs. So the overall should be a lower running cost for the customer.
Okay, and is there a low profile model that will fit under a covered that will fit under a covered orchard like table grapes or kiwis?
That's a difficult question. If we are going through orchards, if they are not completely covered, we don't know if we can get the GPS receiver more or less. If it is completely covered, I don't have the guts to answer the question. But if we can come very close to the top of the crop, then we certainly can. Till now, we did not have a problem.
Yeah, I could perhaps add to that. I mean, it's all down to the GPS position and the quality of the GPS position. Provided the unit can see enough sky and maintain a quality position, then it will operate. But plainly, if you've got massive leaf cover and you can't maintain a GPS position, that's not going to be somewhere where it's going to work successfully.
Okay. And is there an acres per hour performance comparison against a fixed size conventional tractor in various tasks?
If I understand the question correctly, what the output of the robot is in comparison to a tractor, huh? Now, I would say per horsepower, the robot has even a little bit higher output than a standard tractor because the efficiency of this machine is higher, and that has to do with the electrical drivetrain. Electrical means hybrid, so there is still a diesel motor on board, but behind the diesel, everything is electric. And why is the efficiency so high? That has to do with that the top speed of this tractor is only 30-40 km an hour. And then the next thing about output, this machine can run 24 hours a day. So the robot will definitely making more hours than a standard conventional tractor. So very often we compare a 150 horsepower robot with a 250 horsepower tractor. And even then the output is better from the robot.
I would just add to that slightly in that when we were running some tests with the robot last summer, we were using it to pull up some potato beds from some bed work for potatoes, and historically that's a job that takes a lot of skill. You have to be in the right place before you start. You have to line up. You have to, there's a little bit of moving around in the headland and whatever. We planned the job on the portal, we hooked on the implement, and we let it go. So I guess that was a bit of a there was more emphasis on it there, where normally a job would just be completed, but we knew exactly how long that job would take, and it took that long. There was no stopping to align the machine. There was no stopping for a chat. There was nothing. We knew everything was set in the machine before it started, and it went and it did the job. It did it in exactly the time that it was supposed to do it, and that was the end. So in that brings pretty decent efficiency.
Okay. Will, is it possible to have high ground clearance for vegetable crops?
Yeah, obviously that's dependent on the wheel arrangement that you have. Be interested to know what vegetable crops we're talking about. It is quite a small machine, so it does have that limitation of the height over, say a very large self-propelled sprayer. So there are some limitations there in terms of the height we can achieve.
Yeah, comment to that is we are now going into the market with these 3 machines. We are gathering a lot of experience in next coming year and 2 years. And then based on the technology we have, we will see what comes first and what comes after. I mean, it will certainly not stick to these 3 models.
Okay. And how much is the investment cost of an AgBot, for example, a W4?
Shall I answer the question?
Sure.
I can answer a little bit the question because I don't know what the currency rate euros dollar is right at the moment.
Yeah.
And apparently in the Brexit they also don't after Brexit they don't know anymore. But
it depends a lot on the configuration, because there's so many different there's so many options that we can add to it or subtract to it. It's it's a bit of an open-ended question, that one.
Yeah, that makes it a little bit difficult. But let's say if it is an average optional machine, we are talking about 300,000 euros for a track machine, 200,000 for the four-wheeler, and somewhere about 180,000 for the three-wheeler.
Okay.
Which means, yeah, in dollars, I think you have to lower it with 10%. But
Okay.
that's roughly the indication.
Good. Then another question probably to you, Ayo, is how does AgXeed handle the safety aspect? What happened to get this certified?
Yeah, that's a very good question, and that was actually the starting point of the company, because a lot of people say there is not a law about for autonomy, so you can't do it. But the thing is that although there is not a special law for autonomy, that does not mean that there is not that there are not rules for according to machine guidelines. So there is a machine guideline, and you have to fulfill the machine guideline, and that makes it so heavy. So if you take the driver out of the chain and you have to fulfill this machine guideline, and you do, for example, a risk analysis, then you are ending up that you need very special sensors, very, very high specification for an ECU, for a computer or computers. And that makes it very hard. What that also makes it hard is that these type of components which are in your safety chain, you also have to calculate what the mean time between failure is. So how often is a sensor failing? How statistically seeing, how often is an ECU failing? And taking that into consideration, that makes it hard. So, but we have done that. We are doing this together with the German TÜV, which is basically the highest standard in Europe. That's, Germans, they are quite how do you say that? Strict
Particular.
in these type of things. Yes. And that is what we are fulfilling. So, for example, just an example, if you are sending a task to a machine, how are you going to control that the task is not going to the wrong machine, or how do we secure that nobody is hacking the machine? And it means that if we make a task in the portal and we are going to send that to the machine, we are coding the task, and only that particular machine can decode the task. So every ECU on the machine has a so-called HSM module and hardware security module, and only that particular ECU can decode the task. That means it is hardly impossible to hack the machine. And that's the same with the sensors. So, for example, there are sensors on the machine which have an MTBF, a calculated MTBF by the supplier, which is close to 20 years, which means actually that the sensor can hardly fail. And then, for example, we have a GPS system on board, which is not a standard GPS system like tractors have. We have, for example, 2 GPS receivers on board. That means that we know all the time in which direction the machine is standing. These GPS systems are also checking each other. So if they calculate a complete different position, then the machine is sending an error and is not going to move. And then, of course, we are also having the digitally boundary around the field, which is a kind of a digital fence, and the machine never can go out of that fence. So there are a lot of steps in the whole process to fulfill the machine guideline and to guarantee the safety and security of the machine.
Okay, and one question to add that do you have any perception systems active? So, for example, forward, rear camera, radar, ultrasonic.
Yeah, it's all on board. Yeah, so what we also did when we started the project was taking an insurance company within the project. So from the beginning on, they could look to us. We explained them all the time what we are doing, and yeah, they were more or less part of the project.
Okay. In the future, can the robots cooperate with precision farming technology, such as variable rate control?
Yeah, absolutely. That is already now happening. So if you see the machine on which is behind me, then we were already doing that. So we can use application maps on top of the task.
Okay. Another question. What do you think the second-hand value will be after 5 years in comparison to a tractor, for example?
Yeah, that's a very good question. We can't answer that question. It's as simple as that. I said a couple of times, if you are using it at least 2,000 hours a year, you also can say it will be zero. But we also can answer the question in another way. I worked for Lely for a couple of years, which is almost 20 years ago, and they always had the same questions, and they had basically to wait till the second-hand robots were coming into the market. And then it was surprisingly how high the value of the second-hand machine was. Actually much higher than they expected. So the nice thing about the hardware is that the software will develop much faster than in the future than the hardware. I mean, the new features, the improvements will come for 80% not on the hardware, because actually it's a standard tractor with standard hydraulic valves with a little bit more sophisticated PTO, because it's a variable driven electrical PTO. But for the rest, yeah, most of the features will come from the software, which means that I think that the residue value will be even higher than a standard tractor.
Okay. And what is the maximum slope all three can drive up?
Oh.
The one behind me.
Yeah, we to be fair, we've had a little bit of a joke about this one, because of course the product was developed in Holland, so you know.
Yeah. No, the joking apart, the image that is behind me here was taken on the first day that we had the robot test in Scotland, and yeah, we had a lot of rain that day, and we chose to take it to the Angus Glens here to I couldn't give you a gradient, but it's got some very steep parts to it, and yeah, we were cultivating grassland, so it was yeah, and it was permanent pasture as well, so it taken a bit of take a bit of pulling, and yeah, there was absolutely no issue with that at all. It just sailed on through.
Okay. Has the robot been used in vegetable salad crops?
Yeah. And now we have sold now the first track machines on a narrow tracks, so 300 millimeters tracks, and one on 1 meter 80 and one on 3 meter track width. So the track width is completely variable from 180 till 320. And that means that the machine can also work in vegetables. Basically, it's designed for that. Yeah.
Okay. Are you looking at methane or hydrogen in future developments?
Yeah, we don't have a project yet, but you can imagine that because the machine is electrical driven behind the diesel engine, that in the future there will definitely come projects to remove the diesel and add or a fuel cell instead of the diesel engine, or we are going to use hydrogen in a more or less standard engine. And maybe for the lighter machines, battery could be also a solution, but certainly right at the moment not for the heavy jobs.
Yeah, Leonie, that's actually something that I'm quite keen on to look at hydrogen, and it's a project that we might be looking at for our own farm at some point in the next 18 months as to whether we can actually adapt our own farm to a purely hydrogen system.
Yeah, this is definitely going to happen.
Okay. Then another question, I think, to yours. Is AgXeed open to working with research centers to develop alternative engine layouts? So, as well the hydrogen.
Yeah, actually, it is a part of our philosophy. Don't develop everything by yourself, but look for the right partners who have quite some experience in certain fields. So we also are now developing with a lot of development partners and universities and institutes. So absolutely.
Okay. Looking for the questions.
So please, if you have interest to work with us, contact us. And of course we are working with companies, institutes, and universities abroad.
Okay. Then there's a question: what is the value proposition versus GUSS?
I don't understand the question. GOSS.
GUSS. Gus.
Gus. Yeah, that's a good one. I think the value proposition is that we are working together with a manufacturer in Europe. So we are spraying based on sensors, so based on measuring the biomass and all these type of things, fulfilling the spray requirements how they are in Europe. And that is something completely different than Gus is doing in California. I know that a little bit because we are also approached by farmers in California who wants to work according the way how we are doing that in Europe, because chemicals is becoming an issue all over the globe. But I don't know if this is exactly answering the question.
Okay. Then another question about the warranty. What is the standard warranty of the machine?
Yeah, 12 months. Sorry, Joris, do you want to take that one?
To be honest, you have to ask our sales team. I'm not really.
Okay. Yeah. So standard 12-month warranty on the machine, and then we can extend that up to 3 years. At this stage, it's a 3-year extended warranty that we can add at the cost at the point of purchase, and we can also add a service package into that as well. So we can actually define the cost of ownership for the first 3 years with surety.
Okay. Then another, I think, interesting question. If you have 2 machines in the field, can the machines communicate together, share the location, task completed, for example?
Not yet, but that is absolutely coming. I mean, that is on the roadmap.
Okay. checking which ones didn't cover yet. Another maybe technical question: does the AgBot use ROS inside?
I think they mean the ROS operating system.
Yes.
Yeah, and that yes, we are using ROS.
Okay. And I think we have covered all the questions so far. No one has any other questions, then I think we can wrap it up. That's another one coming in. The extended warranty, is that through AgXeed or third-party Green Shield?
Yes, through AgXeed, delivered through the reseller. So we would be responsible for delivering the service, but it's backed up by AgXeed.
Yeah.
Okay. And I think those were all the questions. Thank you all for asking so many interesting questions and your enthusiasm for the AgBots. Thank you, Joris, Graham, William, for the information.
You're welcome.
Yeah, of course, if anyone's would like to talk about it further, just get in touch. And if anyone wants one for harvest, give us a shout. We'll get one organised.
Yeah.
Yes. Good. Then I wish you all a good evening.
Yeah, the same to you all. Bye.
Thank you very much, everyone.
Yeah, thanks
Thank
everyone.
you.
Thanks a lot.
Good
Thanks,
evening.
Leonie. Cheers.
Cheers.
Bye-bye.
Bye-bye.